Welcome to The Explainer. I want you to think about the world around you just for a second. The sidewalks, the buildings, the bridges, pretty much all of it is built with concrete. But this material, the very bedrock of our civilization, is going through this quiet but massive revolution. And that's exactly what we're going to get into today.
It's so easy to just take it for granted, isn't it? But, from the ancient Roman Colosseums all the way to the skyscrapers that define our cities today, concrete has been the absolute backbone of human progress. It's strong, it's versatile, it's cheap, and that's why it's the most used building material on the entire planet. But, and this is a huge but, this incredible material has a massive hidden cost. Producing cement, which is the key ingredient in concrete, is responsible for a staggering 8% of all global CO2 emissions. To put that in perspective for you, that is more than the entire aviation industry combined. So right away, we're facing this huge paradox. We need more concrete than ever before because our cities are growing like crazy all over the world, but at the same exact time, we have to slash our carbon emissions to hit our climate goals. So how on earth do you solve that puzzle? Well, to figure out how to solve it, we've got to get to the root of the problem. And it all lies inside modern cement, specifically in its most polluting ingredient. It really all comes down to this one substance called clinker. The best way to think about it is like the active ingredient in the concrete recipe. It's the part that gives cement its strength, its ability to bind everything together. The problem is, making it is an incredibly dirty process. Making clinker is like a perfect storm for pollution. It's a real 1-2 punch. First, you have to heat limestone to over 1,450 degrees Celsius. Just doing that triggers a chemical reaction that releases a ton of CO2. And second, how do you get your kilns that hot? Well, you burn enormous amounts of fossil fuels, which, you guessed it, releases even more CO2.
Just let that sink in for a second. 90%. All of the carbon emissions from making cement, 90% of it comes from making this one single ingredient. The target for making things better couldn't be any clearer. So, here's the crucial point. If we can fix the clinker problem, we can pretty much fix concrete. And the first and honestly most exciting way to do that is by changing the recipe itself.
Okay, so one of the most promising ideas out there takes the recipe problem head on. It's called LC3. It stands for limestone calcinated clay cement, and its genius is really in its simplicity.
The strategy here is basically dilution. You're watering down the bad stuff. LC3 cement works by cutting the amount of clinker by up to half, and then you just replace it with a mix of limestone and a special kind of treated clay. And the best part? Both of those materials are incredibly abundant all over the world.
And the result of that simple recipe change? You reduce the final CO2 emissions of that cement by a mind-blowing 40%. And you do it without losing performance. This is already happening, by the way. Companies in France and Colombia are already pumping out millions of tons of this stuff. But innovators aren't just stopping at the cement. They're also rethinking the aggregates, the sand and gravel that make up most of the concrete's bulk. Instead of just digging them out of the ground, which tears up the landscape, companies like Brimstone are developing materials that can actually absorb CO2 from the air while they're being made. Okay, so we've changed the recipe. The next big frontier is to totally reinvent the manufacturing process itself. So remember that crazy hot fossil fuel guzzling heat you need for clinker? Well, companies like Synhelion are pioneering something radical. They're using huge fields of mirrors to focus sunlight, kind of like a giant magnifying glass, to create clean heat. Others are using biomass or even industrial waste, basically turning one environmental problem into a solution for another.
Okay, but what about the emissions that you can't get rid of? The CO2 that's just part of the basic chemistry. That's where a technology called carbon capture and storage, or CCS, comes into play. And it's a powerful one. And listen, this isn't just some futuristic idea. The Heidelberg Materials plant in Brevik, Norway, is already doing it. It's a world pioneer. They are capturing 400,000 tons of their CO2 emissions every single year and then permanently storing it deep underground beneath the North Sea. But what if, instead of just burying that captured carbon, you could actually put it to work?
That is the absolutely fascinating idea behind CarbonCure's technology. They take captured CO2 and they literally inject it directly into fresh concrete while it's being mixed. So once it's inside the mix, the CO2 has a chemical reaction and it mineralizes. It turns into these tiny, solid particles of rock. It becomes a permanent part of the concrete, locked away forever. And here's the key takeaway, the real kicker. It actually makes the concrete stronger by up to 10%. You're turning a waste product into a valuable asset. Okay, so finally, we have to solve the end-of-life problem. Concrete buildings don't last forever. So what happens when one gets torn down? We can't just keep piling it all up in a landfill. And this brings us to this idea of a circular economy for concrete. It works in two main ways. The first is cascading, which is all about designing buildings from the get-go so they can be easily taken apart, and those big pieces can be reused. The second is recycling, which deals with the rubble, processing it, and turning it back into something valuable. The recycling process itself is pretty straightforward, but its impact is huge. The demolition waste gets collected and crushed up. Then powerful magnets pull out all the old steel rebar, and what you're left with is a brand new source of aggregate for the next generation of concrete. That means less landfill and less need to dig up new materials from the earth. So, when you step back and you put all of these different innovations together, the recipe, how it's made, what happens at the end of its life, the future of concrete starts to look radically different and a whole lot greener. See, this isn't about finding one single magic bullet. It's about having a whole new toolkit. We can build with smarter recipes like LC3, use aggregates that actually soak up carbon, power the whole process with clean energy, capture and even use the emissions, and design our buildings for a completely circular life. The technology isn't science fiction anymore. It's here. The real challenge now is getting industry, governments, and researchers to all work together to roll these solutions out at scale, to transform the very foundation of our modern world from a climate problem into a climate ally.